job to do here on this Fusee. It's at some point been extended. It was originally either a much shorter Fusee, or there's been some damage at the top end here, possibly to do with the stopwork, which has caused them to put a new nose on the end of it at some point. But the problem is that, can you see how the top few turns dive off at quite an acute angle? So if I just present a straight edge here, you can see they dive off quite suddenly at quite a steep angle. Now the trouble is, this is about the smallest kind of diameter that you're going to want anyway, but by the time you've dived off at this kind of steep angle, you end up with a really tiny diameter at the top here, and it's causing power issues with this clock. It hasn't got enough power when it's fully wound. So what I'm going to do is I'm going to turn off this section at the top here and replace it and recut the thread, but I'm going to make it parallel from the point back here, so that it's because the clock works very well at this point here. So I'm going to just make it parallel all the way along, so that we don't reduce the diameter down as steeply as that. So that's the job for today. Now you can quite clearly see the joint lines where the Fusee has had the extension piece fitted, and if you look carefully you can also see that the lands of the threads are much thicker on the original part, and you can see they're much thinner on the part that has been replaced. So I'm going to try and replicate the thicker sections of the original part as I replace this this extension piece. I just thought it would be good to point out the joint line there. I don't know if this will work or not, but I thought I'd try just heating it up and seeing if the soft solder joint would break, because you can clearly see that the extension has just been soft soldered on. Bingo! Now there really is no doubting what's happened to it. So the job then is to make this part fitted to there and get the clock going. Right, and after much messing around, I managed to get this chucked up in the lathe. But I think if you look at the indicator, can you see the indicator? It is waving around a bit, but I think that's largely because the journal that we're indicating on is not actually round. It's been sort of filed up over the years and is not a true round journal, so we're getting a bit of a indicator wobble because it's acting like a cam really. So it's in as accurately as it needs to be at this stage anyway. So what I'm going to do as the first stop is I'm going to turn off this this solder here. What we'll do then is we'll machine a slug of brass that we can soft solder back onto this and leave it all oversized in every dimension, and then we can machine this directly. You need to just decide what this slug is going to look like. So 6.6 is the bore, and we need it to be approximately 18.6 long. Let's go over to the Smart & Brown and make a blank. This is probably why it's a good idea to clean up after each job, because then you don't have to clean it up before you next go to the machine. So give myself a little bit of a telling off for leaving the machine dirty. And cut to the lathe being nice and clean. Right, so back at the bench, we've got the Fusee here with the old section, which was just soft soldered on, as you saw before. Then this is the blank slug that we've just turned up on the Smart & Brown. I've made it so that it's a good fit, but it is a sliding fit, so that will allow the solder to run up the joint. I've also put a reasonably hefty countersink on the inside, and again on this part on here I've put a bit of a countersink, so that when the solder runs it will pull in that joint there and make a good bond, because we don't want this to move, because this is going to have the stopwork on it. Okay, I'm pretty happy with that joint. The solder has flowed all the way through, and I think that's going to be a pretty strong joint. I don't think that's going to go anywhere. Right, so I've just been to the grinder and I've made up this tool, and I used the collet block here to get the angles on it. Unfortunately, my D-bit grinder is out of action at the moment, otherwise I would have loved to have used that. But anyway, I've made up this tool, and this is now ground to act as a cutter for replicating the grooves in this fusee. Okay, so you can see the angles on the cutter here. It's just a very simple cutter with relief, which is going to plunge cut the thread for the groove for the fusee chain. Now, after I've made the cut, I'll almost certainly need to just tidy up the tips of the grooves with a file, but we'll cover that when I get to it. But that's the cutter for now, and that will go into the grooves of the fusee like that. I'm now going to take the diameter down to match the smallest diameter of the older part of the fusee. Again, I'm just going to go at it very gently, taking very light passes. I'm just about ready to take it out of the lathe now, and what I've done is to just tidy up the bearing surface before, well, I'd still got it mounted concentrically in the lathe. So I used a pivot file in the traditional way on the pivot, and then I used a burnisher, and I usually do it from underneath actually with a burnisher. And then I can see what the surface is doing and really sort of play with the burnisher and get it giving me a nice finish. So that's probably not the final finish of the pivot, but at this stage it was a good idea to take advantage of the concentricity. Finally, before taking it out of the lathe, I'm going to turn down the face here to give me the space to have the stop work, the snail for the stop work, and I'm going to do that with a sort of a centre boss for it to mount on concentrically, and then it will be fitted with 2 screws. Okay, so the next stage is to cut the threads. This is essentially a screw thread on the old part of the fusee here, and in order to carry that onto the extension, I need to know the pitch that this part is cut at already. So to do that, I need to measure the distance that a known number of threads takes up, then I can work out the pitch. So I've done a couple already off camera, but what I'll do is to go from maybe this one, let's mark it up, go from maybe about here to let's do as much as we possibly can, so here. So starting from there, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 full turns over a distance of 0.882 of an inch. So we counted 10 full turns over a distance of 0.882 of an inch. So previous samples that I've taken, over 6 turns 0.0878, and over 10 turns 0.0882, so we're kind of homing in at around the 88. So if we take 1 and divide it by 0.0882, that will give us 11.34 as the pitch for that. So the previous one came out at 11.39, so we're getting there. We're getting to around the kind of 11 point, probably about the 11.35 kind of mark. So we'll have to go over to the Smart & Brown and see what threads are available. Okay, so I've had a quick look, and if we convert our numbers into metric, things work out a little bit better. It means that we're aiming for a pitch of approximately 2.2. So if we look here, 2.2mm pitch on the metric pitches, that means we're going to want a driving gear of 55, a driven gear of 120, and then another driven of 127, and we're going to set the Norton box to 10. So let's have a look how we're fixed so far. So far we have a driver, we want 55 and we have got 60, so that needs changing. We want 120 and we've got 120, so that one's okay. And we want 127 and we've got 127, so that one's okay as well. So we just need to change the driver up here and we should be good to go. Just looking at the spanners to do this job. I'm a sucker for this kind of thing. This is an original spanner to go with the lathe, Smart & Brown. Which, nice that that's still knocking around. Anyway, so what we're going to do is we're going to change out the top, which is the driver. So now we've got 55 on the top, 120 and 127, which is what the chart is calling for. So the next thing we need to do is to put the Norton box into 10. So this is the Norton box fitted onto these Smart & Brown lathes, and we want 10, which means we need the dial position to be in number 4. We need the knob to be in position Y, which is this one here, and we need the lever, the selector lever, to be in position C. So selector lever is already in position C, so that's okay. Move that over to position Y, and then slacken this off here. And move this round 2, 3, 4, okay, and then walking back down again. Okay, so idiot check, we want 10, so position 4, 4, and we want Y, Y, and we want the lever in C, C. Okay, so that should, if we put this into screw as well, that should now be going to feed the carriage at 2.2mm pitch. Okay, so I've dialed that in pretty well. You can see it's within about 0.02 of a millimetre, so it's good enough for this operation. So the next thing I'm going to do is mount up the tool in the machine and see how it looks. See if the pitch that we've set the machine to looks similar to the original part. I thought you might just like to see this nice little tool here from Edge Technology for raising up cutters to their centre heights. I mean, normally you would use it in the headstock to set your cutter heights, but in this case you can also do it in the tailstock, because obviously ideally your tailstock is going to be on centre. So we are a mile away at the moment, so let's just raise up the tool holder, and you can see the spirit bubble start to move as we get closer to the centre height. So what I tend to do is go slightly under, just nip it, and then you can pull it through with the adjuster here. Spot on. Let's make sure it's still spot on when it's tightened up, which it is. So that's brought our cutter up to the centre height.